A famous, harmless, space rock is about to put on one of its best shows in years, yet most people won't even know it's happening. And this is the part most people miss. This visitor isn't just any asteroid, it's the very first near-Earth asteroid humans ever discovered, and it has a long history of changing how we explore the solar system. 433 Eros, often described as an old friend of planetary scientists, is about to make a relatively close pass by our planet, and then remain visible in the night sky for several weeks, if you have access to even a modest telescope. Instead of being a one-night spectacle, it will be a slow, ongoing, guest appearance that dedicated sky watchers can follow over time. On Sunday, November 30, 2025, Eros will swing past Earth at a distance of roughly 60 million kilometers, or about 37.2 million miles, which works out to around 0.4 astronomical units, the standard measure of the distance between Earth and the Sun. That might sound alarmingly close, but astronomically speaking it is a very safe gap, far outside any realistic impact concern, while still near enough to make the object relatively bright, and well worth tracking. But here's where it gets a bit controversial. Events like this sometimes fuel online panic about hidden impact risks, even though this particular flyby is thoroughly monitored and firmly categorized as non-threatening. During this approach, the asteroid's path will take it just a few degrees away from the bright central region of the Andromeda Galaxy, our closest large galactic neighbor in the night sky. For observers, that means a rare chance to see a moving object from our own solar system gliding past the delicate smear of light from an entirely separate galaxy, an alignment that can make for a striking visual, and for astrophotographers, an especially compelling target. For beginners, you can imagine it as watching a tiny, fast-moving pebble cross in front of the soft glow of a distant city scene on the horizon. Eros is not a small speck of debris, but a sizable stony asteroid, measuring roughly 34 by 11 by 11 kilometers, about 21 by 6.8 by 6.8 miles, shaped somewhat like an elongated, lumpy peanut. Because of this relatively large size and its proximity during the flyby, it will be bright enough to pick up using a fairly modest telescope with an aperture around 60 millimeters, which many hobbyists already own, or can access through local astronomy clubs. In practice, that means backyard observers with basic equipment will have multiple chances over several weeks to catch it inching against the background stars night after night. If you do not have a telescope or clear skies, or you simply prefer to watch from the comfort of your home, the event will still be accessible online. The Virtual Telescope Project, in collaboration with the Asteroid Foundation, plans to host a live broadcast of the encounter on November 30th, at 8 p.m. Universal Time Coordinated, 3 p.m. Eastern Standard Time, via their website, virtualtelescope.eu, offering guided views, commentary, and likely real-time imagery of Eros passing near Andromeda. This kind of live stream can be especially helpful for newcomers, as the hosts usually explain where the asteroid is in the sky, how it moves, and why the configuration is scientifically interesting. Historically, Eros has a special place in astronomy. It was first recorded in 1898, and went down in the record books as the earliest known example of a near-Earth asteroid, a class of objects whose orbits bring them into the general neighborhood of our planet. The discovery is typically credited to German astronomer Gustav Witt and his assistant Felix Link at the Urania Observatory in Berlin, since Witt's team was first to publish the finding of this new celestial body. However, French astronomer Auguste Charlois at the Nice Observatory independently identified the same object around the same time, which raises an interesting question: whose observation truly counts as the discovery when multiple astronomers spot the same thing almost simultaneously? From that point on, humanity's relationship with Eros only deepened. A century after its discovery, in 1998, NASA launched the NEAR Asteroid Rendezvous Shoemaker spacecraft on a dedicated mission to study this single asteroid up close, a bold move at the time, when visiting such small bodies was still relatively new territory. The spacecraft approached to within about 3,800 kilometers, 2,400 miles, using its suite of instruments to build up a detailed picture of Eros' size, shape, rotation, and surface features, transforming it from a fuzzy point of light into a well-characterized world. A particularly poetic milestone came on February 14, 2000, Valentine's Day, when the spacecraft entered orbit around Eros, making it the first asteroid ever to be investigated from within its own gravitational embrace. The romantic date was fitting, given that the asteroid is named after Eros, the Greek god of love, and public outreach around the mission leaned into that symbolism to capture people's imaginations. Orbiting Eros allowed NEAR Shoemaker to map its surface at high resolution, study its craters and boulders, and refine estimates of its mass and internal structure over an extended period. By 2001, the mission team attempted something even more ambitious, gently bringing the spacecraft down to land on the asteroid's surface. This maneuver effectively turned an orbiter into a lander, and marked the first time a human-made object had successfully touched down on an asteroid, an unprecedented achievement in space exploration. Officially, that landing was supposed to mark the end of NEAR Shoemaker's mission, with expectations that the craft would shut down shortly after impact. What happened next surprised almost everyone involved. Instead of falling silent, the spacecraft survived the landing in good enough condition that many of its instruments remained operational, allowing NASA to continue gathering data from the asteroid's surface. This unexpected bonus phase enabled the first gamma-ray measurements taken directly from the surface of a celestial body other than Earth, giving scientists unique insights into Eros' composition, and providing proof that sensitive scientific hardware can function even under the harsh conditions on an asteroid. Because of experiences like this, Eros has become a kind of testbed rock that helped demonstrate how future missions might land on, sample, or even one day mine asteroids without immediately destroying their equipment. Some researchers view it as a proof of concept for more ambitious exploration and resource utilization plans involving small bodies, though others argue that the technical and ethical hurdles of asteroid mining are still vastly underestimated. Do you think using asteroids as potential resource hubs is an exciting next step, or do you see it as a risky overreach? So, if you manage to spot 433 Eros sailing past the stars in the coming weeks, whether through your own telescope or via an online stream, you'll be looking at far more than just a moving point of light. You'll be greeting an object that helped rewrite the story of how humans explore near-Earth space and landed the first spacecraft on an asteroid's surface, quietly reminding us how much can be learned from a single, persistent target. And here's a final thought-provoking question. Does knowing this history make you see Eros as just another rock in space, or as a kind of veteran explorer that deserves a bit of gratitude every time it swings by? Share where you stand. Does this feel overhyped, or do we still don't pay enough attention to moments like this?